All right. Hello, everyone. Once again, we are now getting into section 3 of chapter 1, which is working with rational expressions. So, in this video, I am not going to be doing this from ground zero. This is a topic that you have had in the past. I am going to be reviewing it. I am not going to be starting at the beginning. So, if you are struggling with it, you might need to go back and ask me some questions, or you might need to do some research on your own. But the key word right here is that we are talking about rational expressions, and when we see that word rational, we are referring to fractions. So we are going to be focusing on how do we simplify fractions, how do we add, how do we subtract, and how do we multiply and divide, is what we are going to be working with today. Also going to just take a look at some complex fractions as well, but we'll see how those are going to pretty much work right in what we've already done. All right, so let's just talk about real quick here what a rational expression is. I pretty much already did that, but it is the quotient. That means that we are looking at the fraction of two polynomial expressions. All right, sorry. I had to let my dog into the room that I'm in right now because she doesn't like to be away from me. All right, so a rational expression is the quotient of two polynomial expressions. And just a reminder that, when you divide something by itself, you get 1. So when we see here that x plus y divided by y plus x, those are the exact same things, okay? If you were to take 2 plus 3, divide that by 3 plus 2, you're getting 5 divided by 5, and that is indeed equal to 1, okay? They're canceling each other out. Also, what you want to be aware of sometimes is if you have them negative, be aware that with subtraction, order does matter. So x minus y and y minus x. Now, those do not cancel out to be positive 1. They do cancel out to be negative 1. And just to kind of show you real quick, if I were to factor out, say, a negative 1, that would leave me with negative x plus y divided by y minus x. Now, what's happening is those two right there, those are equal to each other. And that is why this is now equivalent to the negative 1 versus the positive 1. So when we get into rational expressions, the big thing here is trying to simplify them down. And the only way that we can simplify a fraction is if you have the same factor in the numerator and the denominator. Just kind of a side note here, I know I said I wasn't going to go into too much detail, but say you have something like 3/6. You guys all know that that is equivalent to 1/2. Now, if I were to really talk about this here and I break it down into its prime factorizations, okay? So 3 is a prime number. So technically it's 3 times 1, but I don't need to have that 1 there. 6 is the same thing as 3 times 2. Now, because the 3 and the 2 here, those are what are referred to as factors. And actually, maybe I will put the 3 times 1 up here. That might be a little bit easier. All right, so 3 times 1, 3 times 2, that is the prime factors, 4, 3, and 6. Now, what's happening here is because the 3's are factors of the numerator and denominator, and be a factor, it has to be multiplied, I can cancel those out, and that is what is leaving us behind with the 1/2. Same thing if I were to do, let's just go 15 over, I'm going to go 45. So when you think of 15, we can break that up into 3 times 5. And right there, that can't be reduced any further. Factors of 45, well, we can do 9 and 5, but I can break that up even further into 3 times 3 times 5, and then I've got my 3 times 5 up here. So just kind of showing you what's happening here is all of these are factors, so the 3's cancel, my 5's cancel, and then we are left with the 1/3. In order for something to cancel, it has to be a factor. It is not going to be the same thing. Say that I have 3 divided by 5 plus 1, Okay, I can't do anything with that. Same thing maybe I should do here. Let's go 3 plus 3. Okay, in this situation, I cannot cancel the 3's here. This would then be equivalent to say 1/3, and we know that 3/6 is not 1/3. It has to be a factor. It has to be multiplying in order for that to take place. All right, so I feel a sneeze coming on here. 1 second. All right, just nick of time there. All right, so I'm going to take a look at number 1, and for most of these problems here, you are going to have to be able to do your factoring, which we did in the last lesson. So when I see the numerator right here, this is actually the difference of two perfect cubes. So it looks like I have 4k cubed minus 1 cubed. And in the denominator right here, I do have a quadratic that we are going to break up. With the cube in the top, I am going to take here's my x and here's my y. So I'm going to have x minus y, so 4k minus 1, that's my first factor. And then I'm going to take my x squared, so that's going to be 16k squared plus x times y, so 4k plus y squared, which then would be 1. Divide this by, and then my denominator here, I don't have a GCF in any of that, so we can just kind of go from there. 4k squared. Usually I like to break it up as a 2k and 2k, but I see a real large number there in the middle, which makes me think that I am going to put a 4k and a 1k to start us out. And then I've got a 3. I do have a negative in the middle, so I'm going to make both of these negatives here. And I'm going to put a 3 and a 1. Now, 4k times negative 3 is negative 12. Negative 1 times 1 is negative 1. So that does give me my negative 13. Now, as I'm looking at this and I see my factors, I can see that I have a factor of 4k minus 1 up above and a 4k minus 1 down below. Those right there are going to cancel each other out. Now, I have to leave the rest of it as is. So we're going to have 16k squared plus 4k plus 1 all over k minus 3. I cannot do anything else. Now I have sums and differences in this problem. We can't do any more simplifying from there. All right, let's take a look at number 2. Number 2, we have two binomials, and I'm going to go ahead, and it looks like both of them have some DCFs that we can go ahead and work with. So up above, I can divide 12 and 48 both by 12. So I can take out 12. I also can take out an n, and that leaves us behind with n minus 4. All right, down below, 288 and 18. I can actually divide both by 18. So we're going to take out an 18, and we're also going to take out an n squared along with that. And that right there is going to leave us with, looks like 16 minus n squared. All right, so we are getting closer. Now, the one thing here is that I can actually factor my denominator out a little bit further here. So I can do 4 plus n and 4 minus n, since it is the difference of two perfect squares. And from here, we can do a little simplifying. All right, so I've got the n minus 4. And, actually, I got to look a bit more carefully at this here. I've got n minus 4, and I have a 4 minus n. So those technically, in the way that they are written right now, do not factor each other out. However, if I were to factor out a negative 1, that would make this a negative 4 plus n. And that right there would cancel out. So that is a little trick that hopefully you remember from Algebra 2. Along with this, I do have a factor of an n up in the top and an n squared. So this n and one of the n's will cancel down there in the bottom. The n plus 4 factor is not going to do anything. The 12 over 18 right here, we can simplify that down. And we can divide 12 and 18, or divide both of those by 6. So that 12 is going to turn into a 2, and the 18 will turn into a 3. And so this is going to leave us with negative 2 over, and then it looks like we're left with 3n times, and I like to write it as n plus 4, but you could do 4 plus n as well. And we can go ahead and leave it in factored form if we wanted to. You could also rewrite this as, let's see, 3n squared plus 12n if you wanted to, but no need to do that. All right, so that right there is simplifying. It has to be in the numerator and denominator. Now we're going to continue with that idea of simplifying as we start to look at doing the operations here. Multiplying and dividing, starting with those because those are probably the easiest to work with. Remember that when you're multiplying fractions, we multiply really just straight across. So what we're going to do right here is I'm just going to extend this because really where I see that multiplication sign right here, I'm going to multiply everything that's in the numerators times each other and everything that's in the denominators. So really that's going to make one big fraction for us. So I'm going to start factoring things out right away. Right here, x squared minus 10x minus 24. So that's going to be x, let's see, minus 12 and x plus 2. That's going to factor out 2. And the 5x squared minus 20x, I could take out a 5x and be left with x minus 4. So notice that's the entire numerator. Down in the denominator here in that first factor, I can take out an x squared and I'm left with x plus 2. And then x squared minus 16x plus 48. Let's see, we can do an x and an x. And I want to do a negative 12 and 12, that'd be 48. So plus 48. Oh, sorry, minus 48. I'll change that. Minus 4 I want. All right, so now when I look at all of this again, multiplying, so I'm just going to go straight across. Now I'm going to look for my factors that are identical to each other. I have an x plus 2 in the numerator and denominator, so I can get rid of those. I can get rid of the x minus 4s, which is great for us. I can even get rid of that x minus 2 or x minus 12. Look at how great this is. Now I've got 5x left on top. I've got an x squared on the bottom, which actually that x on top is going to cancel out with one of the x's down on the bottom. So we are left with 5 over x. All of that right there simplifies down nicely to 5 over x. All right, let's take a look at, I'm going to go, actually, why don't you try and see if you can do number 4 on your own. So I want you to try, here, I'm going to factor this out actually for you. So let's go, we're going to have a 5p minus 1 times p minus 6. All right, so that is over, 5p minus 1. Actually, 1 second here. I want, oh wait, this should be plus 6. There we go, that's right, okay. 5p minus 1, p plus 6, so that should get us right. 29, yes, okay. Down the bottom then here, I can get 5p minus 1 and p minus 5. And we're multiplying over here, 3p squared. So if I take out a 3 and a p, we are going to be left with p minus 5. And then over here, I'm going to get 6 minus p and 6 plus p. All right, so go ahead, see if you can pause it and do that one. How'd you do? Did you get 3p over 6 minus p? All right, then for division, when you are dividing fractions, you are essentially multiplying by the reciprocal. Right here, multiply by the reciprocal. So we're going to take that second fraction right there, and we just want to flip it around. So I'm going to go ahead right here and I'm going to factor out the first part here. So we're going to have 2s, let's see, plus 1 times an s plus 4 all over. That's the difference of two perfect squares right there. So we're going to get 1 plus 2s and a 1 minus 2s. And then since we are dividing, now I'm going to change that into a multiplying and I'm going to flip it around. So I'm going to start with this guy right here. So that's 2s minus 3. So 2s minus 1 and an s minus 1 will work for there. Then I'm going to do the top part of it here. So we're going to do a 2s and an s. And we're going to do a plus 1 and a minus 1 right there. So again, this came from taking that second part and doing the little flipperoo. Now we can multiply straight across. And really, since I'm multiplying, now I can start to cancel anything out that is common. Now, the 2s plus 1 and the 1 plus 2s, those are the same as each other. I do have to be careful because the 1 minus 2s and the 2s minus 1 are not the same unless I factor out a negative, then they would be identical to each other. So here we end up with a negative s plus 4 over 2s plus 1. All right, try and see if you can do number 6 on your own. And what I'm going to do once again is I'm going to try and factor this out for you. So you've got the k to the fourth minus 16. Now that's the difference of two perfect squares. So that's k squared minus 4 and then k squared plus 4. Now k squared minus 4 can be simplified, factored out further. So I'm going to go ahead here. And so that this is factored out completely here. So k squared plus 4, and then I should have k plus 2, k minus 2, all over. And then, let's see, we'll have a 2k plus 3 and a k minus 2. Now, since you're dealing with division, this time we want to multiply, and we're going to flip the numerator and denominator around. So over here, I can take out a 6k in the bottom, be left with 2k plus 3, and my new denominator coming from the numerator here, factor out a 4k, and we're left with a k squared plus 4. All right, so we'll pause it, see if you can simplify that. All right, so you should get 3 times the quantity of k plus 2 all over 2. So don't forget that 6 and that 4 right there, those can simplify each other right there. And that's where that 3 and the 2 is coming from. All right, so now we get into probably the more difficult part of adding and subtracting fractions. Now, in order to add or subtract fractions, you have to have common denominators. And when you think about back when you did this, you know, in middle school, when you start to learn dealing with fractions, factors really do come in handy. And I wish we talked more about that idea of factors. Let's just say that we take 1/3 and we are adding, I'm just going to go 2/5. You guys probably know that the common denominator between these two is going to be 15. Well, how do we get 15? Well, essentially here, we are going to have to multiply the 5 by the 3, but whatever I do to the bottom, I have to do to the top so it doesn't change the number. I would have to multiply the 3 by 5 as well. Well, what I want you to realize here is notice that it's just multiplying these two factors together is a way to do this. Now, it's going to give you a common denominator. Not always will it give you the least common denominator. Let's just say that I want to take 1/6 plus, say, 2/5, okay? Now, again, a common denominator that we're working with here, oh, is this kind of what I want? Yeah, I'm so sorry. Common denominator in this case would be 30, okay? So another way to think about this here is that we'd have to multiply these sides here, both the top and bottom by 6. Here we're going to multiply everything here by 5. And that's what's going to get us. Now, same thing is going to happen when we take 6 times 5. All right, now I know what I was going to do. Different example. Let's say that we take 1/3 and we want to add 5. 5/12. All right, so let's do that one. So a common denominator here would be, well, it's 12. But so one way you could do this is you absolutely could just multiply the 3 by 4 and we can go on our way. Now, you could also instead choose for your common denominator to be 36 if you wanted it to. We could multiply both 12 and 5 by 3, and we could multiply here the 3 by 12 and the 1 by 12 if I wanted to, and we get 36 for our common denominator. Now, that's a common denominator. It's not the least common denominator, but it's a common denominator. And really what you're looking at doing is just take those factors that are in your take the values that are in your denominator and use those as your factors. I want you to keep that in mind as we start looking at using this with rational expressions. So now here I've got 3 divided by 4w minus 2 divided by 5w. All right, so not common denominators, but when I look at the factors in the denominator, I have 4 times w, I have 5 times w. Notice they both have a w, so I really don't have to worry about that because that is the same thing. Now I just have to work with the 4 and the 5, and 4 times 5 is essentially 20. So if I go ahead here and I multiply the numerator and denominator by 4, and then I take over here multiply it by 5, this is going to give us a common denominator of 20w. I didn't do anything with the w. I could if I wanted to, but this will give me the least common denominator versus just a common denominator. All right, so in doing this now, I have 15 divided by 20w minus 8 times 20w. Now, when we are working with fractions, we just do the top part here. So if I go ahead now and I subtract 15 minus 8 would give us 7, and that would be divided by 20w. And there we go. All right, number 8. When you have this minus 3, now think about this as 3 over 1. Now, I love it when it's over 1 because you don't have to do a whole lot because anything works with 1 as its factor. Now, I look over to the left here and I see an x plus 4 in the denominator. So that right there is a factor, so is 1. Well, anything times 1 will give it that same value. So I don't need to take x plus 4 times 1. But I do need to multiply the numerator and denominator on the second part here by x plus 4. So now I have the quantity of 2x minus 1 minus 3 times the quantity of x plus 4 all over x plus 4. Okay. And in this situation, I am going to do a little simplifying real quick here. And I've got 2x minus 1 minus 3x minus 12 over x plus 4. So 2x minus 3x, so that's going to be a negative x and a negative 13 over x plus 4. So here my expression simplifies down. Okay, let's take a look at number 9. Here we don't have any common denominator, but there is one. I don't have to do too much here. R squared minus 25, treat that as R plus 5 and R minus 5. Notice that you already have the factor of R minus 5 over on the right-hand side. The only thing that's missing is this R plus 5. So if I multiply the numerator and denominator by that, we are going to be good. So I'm going to have r plus 5 plus 6 times r plus 5 all over r plus 5 and r minus 5. Now, do not cancel out the r plus 5s, okay? We don't want to do that. We are trying to condense, we're trying to add the fractions. We're not trying to do any simplifying. And I am working with the least common denominator in my case here, so I don't have to worry about that. Do a little simplifying up on top here. So r plus 5 plus 6r plus 30 over, and it's up to you whether you want to, if you want to factor out your denominator or not. I'm going to not yet, just because sometimes we see some things before we do that. All right, so r and 6r, so that's going to give us 7r plus 35 over the quantity of r plus 5 and r minus 5. All right, so things are looking really good, and I love that answer there. There's just one little thing is actually it can be simplified further. If we factor out a 7, we're left with r plus 5, and so notice that that is going to cancel out with an r plus 5 down below. So we're left with 7 over r minus 5. All right, I'm going to try and do number 10 here with you. Kind of very similar to what we saw with number 9. We got the difference of two perfect squares here. So a plus 2 and a minus 2. And so as far as my common denominator goes, I've got a plus 2 in both spots. I just need that factor of a minus 2. So I'm going to multiply the top and bottom by a minus 2. All right, so we got 5a plus 6 minus 1 times a minus 2 all over a plus 2 and a minus 2. Okay, so do a little simplifying up on the top here. We got 5a plus 6 minus a plus 2. 5a minus a, so that's going to give me 4a. 6 plus 2 is 8. So notice we've got a little bit of a simplifying that we can do here. I could take out a 4 and leave behind an a plus 2, and that is going to cancel out with an a plus 2 down below. And so we're left with 4 over a minus 2. All right, so what I'm going to challenge you to do here is try and see if you can do 11 and 12 on your own. Pause the video, obviously, and then unpause it and see what you see if your answers match up. All right, and here we are for 11 and 12. With number 11, once you factor out that q squared minus 7q plus 12, just notice that you have it at q minus 4, which you see in that first fraction. So really you just have to multiply that first fraction by the q plus 3, and that's what I did there. Over with number 12 there, your denominators are two completely different factors from each other. So you're going to multiply the fraction over on the left by the x minus 1 and the one on the right over by the x plus 6. Now, I don't want you to be discouraged either as you're going through this. You know, we are at this point definitely trying to hold you accountable to the things that you have learned in previous years. In this world of the pre-calc, I mean, it's just trying to step up a little bit. You are considering taking more of an advanced math class at this point. And, you know, if there are questions, you need to make sure that you're asking them. And really, you're not going to see the same problems that you saw in Algebra 1 or in Algebra 2. You are going to see them being stepped up just a little bit. All right, the last thing that I'm going to do real quick here is I'm going to talk about a complex fraction. And I'm just going to do one of them just because we won't be doing a whole lot of these throughout the the semester, but I just want you to be aware of that. And a complex fraction is just you've got some addition or subtraction along with in a fraction. Okay, so you've got the numerator here that we've got, which is dealing with subtraction, and we've got the same thing happening here in our denominator. My suggestion to you right away is try to simplify your numerator and denominator right away. All right, so if I start with the numerator, I've got 1/10 minus 9 over 40r squared. Common denominator would be 40r squared. So I can multiply here that 10 by 4r squared. I'm going to do that same thing to the numerator here. And that's going to end up giving us, so essentially here, 4r squared times 1 minus 9 all over 40r squared. Down below, I've got a 3 and a 2r. So a common denominator there is going to be 6r. So that means I'm going to have to multiply the 2r by 3 as well as the 1 and the 3 and the 1 by 2r. So now here we would hit 2r minus 3 all over 6r. All right, so now once you've got that part simplified, remember that really we're dividing here. Fractions are divisions. You have quotient. So this idea, the fact that we are dividing here, remember that when we divide by a fraction, it's the same thing as multiplying by the reciprocal. So I'm going to rewrite this now as 4r squared minus 9 over 40r squared, multiply it by 6r over 2r minus 3. Now I'm going to go ahead and simplify right here. This is the difference of two perfect squares. So 2r plus 3 and 2r minus 3 is what that would simplify down to, which is great because the 2r minus 3's would cancel. Since you're multiplying straight across here, my r would cancel with one of those r's. And the 6 and the 40, we can divide both of those by 2. So that would leave us with a 3 and a 20 left behind, right? Yeah. So this is rewritten up here. So we would be left with 3 times 2r plus 3 all over and 20r. And that's what that would simplify to. So with these complex fractions, it's a combination here. You are doing some simplifying and then trying to and do the division part. All right. All right, so that concludes section 3. As always, make sure that you're jotting down any questions that you have. Definitely take a look at doing some of the practice problems. And you will see some of this stuff popping up from time to time.